So now I'm requesting the speaker, Mr. Nitin Swamy, Director, Vayavya Labs. Sir, you are most welcome to presentation. Please, sir.
So they're loading up the presentation right now. So a few thoughts before I get into what I have here. So when I walked in the morning today, I had a strong feeling that I might need to convince a lot of us here about why validation and verification in a virtual domain is important. But to my pleasant surprise, every speaker who came here, starting with Ms. Ujjwala from ARAI, I think the point that was made is that the 4 pillars that was talked about, one of the key pillars that has been highlighted always has been virtual validation, simulation-based validation. Right? And as I kept hearing one speaker after the other talk about the need to gather data, put it in a simulation environment, and then test it, it kind of made sense, and that we as a company, and I personally, I am in the right field, that we've not made a mistake investing in this particular technology. Right? So good evening, good afternoon, everybody. My name is Nitin Swamy, and today we are going to talk about virtual validation and verification for ADAS systems. Right. So let me see how I operate this. Okay. So just like everything, validation is a process, right? And what is validation exactly? Someone comes to you with a set of requirements. So I was in the panel earlier, just 5 minutes ago, and then we had people from the OEMs who were talking about putting their cars out in the market with ADAS features, right? So these gentlemen here come up with the requirements that actually will define what the ADAS system is supposed to do when it's put on the vehicle. And then starting from the fact that something ADAS has to run on a vehicle, to properly taking it through the steps to ensure that everything that is specified as a requirement actually gets tested. That actually encompasses what validation is all about, right? So identify, define, conduct, perform, and conform. Okay. We spoke a lot just before in this panel about recognizing key ADAS functionalities for the Indian market, right? So that becomes a very, very key feature, right? What is it that you really want going on the vehicle as an ADAS feature? Right? And is it enough just to define the feature, or do you need to define metrics for its performance, right? You define metrics, and of course, you need to test the vehicle. How do you test it, right? We have seen that there are about 5 or 6 vehicles outside where systems are fitted where the vehicles actually move, and some things happen, which is the ADAS feature working, and that feature actually gets tested in real time in real life, actually, right? But can that be done for all the requirements that you have? Can that be done for all the key metrics and the safety criteria that you're defining with a real vehicle? Maybe, maybe not. Okay. When you define these series of tests and you define certain performance criteria, they need to get checked against the requirements that are there. Right? So the validation actually is someone tells me I need to define, I need to achieve this acceleration. I take it through all the steps, I conduct the experiment, I gather the acceleration data, and I then compare with what is given to me and say, okay, did I really achieve that acceleration? Right? That becomes the validation. And then finally, is it enough for me to just say that I've tested it once and that's it? Or do I need to keep doing this test over and over again and ensure that every time that same scenario is seen by the ADAS algorithm, it always reacts in the same way and always applies the brake or steers or accelerates in the same way? Right. So this entire cycle actually gets covered when we talk about validation and verification. Some requirements for V&V as such. Right. Data accuracy. We spoke a lot about the Indian market or the Indian traffic being very unpredictable. We need to have the data that tells me that this is the input data that I'm going to operate on, and that data is reliable, right? Because based on that data, I'm actually going to test the performance of my ADAS features. Right? Regulatory compliance, I spoke about it a few times myself. ARAI needs to have some regulations in place that talks about what is it that I can have on my vehicle in India, and what is it that I'll be able to test based on those regulations. Right? Sensors integration, again, we spoke a lot about it just in the past hour. Right? Radars, cameras, lidars, ultrasonic sensors. So what do we need? And what data do we need from those sensors? And finally, the testing environment itself. Right? Does it get tested in a laboratory? Does it get tested on a test track or in the real field, real operating conditions? All these needs to be considered. Through the past decades, a couple of decades, 3 decades probably, a lot of testing methodologies have evolved in the automotive field. Starting from what's here at the bottom, which is what we call real-world testing, right? Which means develop your system, put it out on a vehicle, take the vehicle on the road or on a test track, connect your measuring equipment, and then start looking at signals, start looking at parameters. Right? That's real-world testing. A close cousin of the real-world testing is actually the hardware-in-the-loop methodology, where except for the real vehicle, everything else is real, which means the electronics are real, the software is real, and you have the real ECU that's in the vehicle. But just you replace the vehicle with a simulated model of the vehicle, which runs in a huge, real-time computer that simulates the actual behavior of the vehicle. That makes it hardware in the loop. And we do have my good friends from DSpace showing their agile solution. I have worked with DSpace for, I think, more than half of my life. Right? So 25, 30 years I've been working with DSpace equipment, actually. But then why am I going to talk today about what's on the top here? Simulation-based methods. Right? What happens is, just like we spoke about adding more sensors, making the cost of the vehicle go up in an Indian context, similarly, adding a lot of real-world testing or adding a lot of hardware-in-the-loop boxes for testing in the laboratory drives up the V&V cost. And for all those who have spent a number of years in V&V, I think we all understand that V&V comes at the very end of the entire deployment cycle, where the responsibility is high, the time given to you is less, and if something goes wrong, all fingers are pointed at you, that you didn't do a good job validating. Right? So won't it make more sense if we try to pull this entire validation cycle from the end to somewhere towards the middle or the beginning of the development? Right? That's where I think this simulation-based testing or the virtual validation makes it smart. Okay? We have been doing a lot of this already in different domains. So we do that in powertrain, we do that in body chassis, right? But what makes ADAS different, and why are we spending some time talking about this today? One of my panelists in the previous panel clearly made a statement that it's the environment that is more important. It's an input that comes from the environment when you operate ADAS systems. Right? That is the key feature, why simulation-based methods make so much sense for ADAS V&V. Right? You have the ability to simulate so many conditions of the environment to act as inputs coming into your ADAS feature. Right? You have a simulator that can actually simulate when it is 30 degrees outside or 35 degrees outside. You can simulate the freezing temperature or the freezing conditions of Alaska or the cloudy conditions of Seattle, for example. Right? And all that gets done when the tester sits comfortably in his or her lab in an AC environment, and still they are able to simulate these conditions. Right? And is it just the development part? No. It's the actual code that goes onto the real ECU that also can get tested by doing what is called software-in-the-loop testing. Right? So enabling the environment becomes a very critical factor, right? And that is where simulation-based testing or virtual testing makes its mark in ADAS. Okay? To drive home this point a little bit more, these are the challenges that one would face in real-world testing or hill-based testing, laboratory testing, that is. Right? comprehensive real-life scenarios. Okay, it's going to be very hard to recreate a signal-based scenario that can simulate something that's happening in a climate that cannot be really simulated. So it's hard to get a real-life scenario in something that's not actually in that particular environment. Your vehicle is not in that environment yet. Right? Cost and resource constraints, I've already touched upon this. And I can recount the countless battles I've had with my managers, asking them to give me, one more HIL platform or one more sensor, a real sensor that I can use to test. Right? So it becomes very budget intensive when you have to invest in a full-fledged testing environment with the cost constraints that are there typically when you run a program. Right? Edge case validation. Right? How would someone do a case or test a case where a passenger has actually moved between two fields of view of two radars, one from the center radar and one from the corner radar? How do you actually generate such a scenario in real-world testing? Testing scalability. Right? The current scalability, if you're talking about real-world vehicle testing, comes from having multiple mule vehicles, which are very expensive and drivers are very difficult to get. Right? If it's an HIL system that you're talking about, right, which again mirrors reality, the real-time performance, it's again cost, right? Every unit costs quite a bit of money, and if every engineer starts asking for a DSpace box or a LabVIEW or a National Instruments box, then it increases my capex, right? And data reliability issues, right? So there's a lot of data that can get corrupted when you're trying to run it in a real world, for which it becomes hard to actually manage that data. Okay. So a preferred methodology, which has been again time and again mentioned since morning today, is simulation-based ADAS V&V. Right. And so what happens here, right? Everything that we know has a digital twin representing it. So you have the environment getting represented as a digital twin. You have the vehicle itself getting represented with math and physics as a digital twin. You have the ADAS algorithm that's already present in code with us, right? And you need to have some trigger for it, the environmental scenarios, which also can come in through scenario creation. So you can actually create scenarios with certain specified standards from ASAM called open scenarios. And you can bring all of this together in an environment that allows us to seamlessly do testing for a lot of the ADAS features, right? If you look at what happens today in a laboratory environment with, let's say, a Hill system, 60 to 70% of the testing that happens is on functional testing, right? A lot of this functional testing actually can move into the simulation environment, because we're not going to talk about timing, for example. We only are talking about the functionality. And yet, we insist on testing them at the HIL bench because we have it available, right? But for an ADAS system, the number of scenarios which are required to test becomes humongous. And it's going to be impossible or next to impossible for us to have one HIL setup to test everything, or one mule vehicle to test all these scenarios that can crop up. Okay? So we would, or the way forward would be, considering left shift, considering the fact that you'd like to pull up the validation cycle more towards development, and to also keep a cap on costs. A natural movement would be towards simulation-based ADAS V&V, right? Improved efficiency is something that can happen here. Cost reduction, because physical prototypes are minimized, okay, as is the physical testing equipment. Increased flexibility. As I said, I can recreate scenarios from all over the world, sitting in the comforts of my laboratory, and make sure that the customer's ADAS stack is actually getting tested as per the requirements. And enhanced accuracy, right? So the more accurate the simulation environments are, the better is the accuracy that we can hope to achieve. How does this simulation execution process work, right? I'm skipping a little ahead, and I would like to say that a live running example of what happens here will be available at our booth number 4, where we actually are showing how to go from a scenario that represents the requirements that needs to be tested to integration with a simulation setup, which runs simulators, and how exactly an ADAS stack is getting executed and tested. Right? So scenarios become our inputs, which is the representation of the environment in which the vehicle runs. The configuration of the environment happens through the simulator interfaces. Right? You have the simulator tools that already provide us certain fidelities of vehicle models and sensor models. These are all integrated together with standard interfaces. You then execute them, and because all this is software, you could choose to run them either on the edge or in the cloud. And you can do lights-off testing, you can do at-scale testing, right? And to ensure that the multiple, thousands or thousands of test cases that are generated from these scenarios actually get tested. And finally, all the result that gets dumped out can then get analyzed. And if there is a case or a test case or a particular set of cases that are failing, you could always go back, refine your scenarios, and look at the requirements and say, okay, can I now rerun it? And rerunning happens at the click of a button, as long as this chain is established. Right? Scaling of an ADAS simulation, very difficult to do in the laboratory, very difficult to do with real-world vehicle testing, but definitely possible with simulation-based virtual testing. So you can have the entire, as I said, because everything is running as software, you can have instances of this software running in different cloud instances. You can connect them all together with standardized interfaces, and you can keep running these simulations, till you figure out, whether your stack has met all the requirements. Right? Multiple users, right? I could have some user sitting in Bangalore, another user sitting in Pune, a third user sitting maybe in Denmark. And they all could be accessing the same setup, running the same simulations in cloud, and then comparing results the next day when they come and meet. Right? So all this is possible if we can, consider moving from more hardware-based, laboratory-based solutions to simulation-based validation and verification. Right? And what this also enables is, if my screen moves, is integrating this entire development with the CI pipeline so that we are bringing our validation closer and closer to development. A lot of development today, ADAS or non-ADAS, happens in an agile manner with a CI pipeline running. So why not include V&V also as a part of the CI pipeline? Right? Can it be done with a real hardware-in-the-loop simulator? Maybe. Right? But the ease of integration into the CI pipeline for a simulation-based testing is, let's say, 100 times more than what it would be for hardware-based testing. Right? So you develop in the cloud, you test in the cloud, make sure that things are working, and then you deploy. Right? And am I saying that 100% testing can be done by this methodology? Absolutely not. Right? We might be able to do 70 to 80% of the testing. The remaining, what remains, actually then can get tested on a real vehicle or on an HIL platform in the laboratory. Right? So how does this help people? Right? You save on costs of, or CapEx, or capital expenditure, on either test vehicles or on test equipment. Right? You only have as many test equipment that are required to cater to those 30% of tests. Right? The remaining 70% gets done in the cloud through this framework that can be established. Right? You are anyway going to have these simulation tools as a part of your development activity. So does it add cost? No. Right? It's still going to be the same cost. There will be cost in setting up the environment, the virtual environment, but that usually is a one-time cost. And once it is set up, irrespective of how many vehicle programs you run, how many ADAS refreshes happen, you'll always be able to run with this kind of a framework. And I believe brings me to my final slide, which is, what are the key takeaways that I would like someone attending the session to go away with? Reduction in dependence on hardware availability and the cost, right? So this is a key takeaway. And someone who's been working with hardware-based systems, testing systems, for a couple of decades now, I can tell you that this really becomes a pain when you have to negotiate with your managers to actually give you more and more hardware to test. Right? Testing scalability, as I said, you can scale. You can have multiple instances running the tests, multiple instances which can be collaborated with by people working on it from different parts of the world. At the end, you're trying to left shift, right? So that's what it enables. Edge case testing, right? We spoke a lot about accident databases. We've been speaking about accidents, defining what kind of testing should be done in India, right? Such edge cases can actually get generated and tested, right, on the ADAS stack if you are running it in the virtual environment, right? And one particular example of this is right now a demo that's available in our booth, at booth number 4, as I said, where we are looking at accidents that are reported specifically in the North American domain, and we have converted it automatically into a scenario that can then run with a simulator, all in the virtual environment. Right? And finally, the left shift, moving testing closer and closer to development with integration with the CI pipeline. Right? So to end, a little spiel about the company. We are founded in 2006 with presence in Belgaum and Bangalore. 18 years now, and are leaders in automotive ADAS A&D scenario design. We work with leading tool manufacturers, developing scenarios and completing the integration, basically achieving their end customers do the left shift and do the scaling, right? So if you've not already come and looked at our demos, please do. It's at booth number 4, right there, where live action demos of what I've spoken about today can be observed. Right? Thank you so much for your time.